Folks, audio check. Check 1, 2. Audio check. Does that work? Awesome, good. And computer screen, can you see it? All right, I'm actually going to be teaching you guys I'm going to be teaching you guys doing a bunch of typing. I just think that the reason why I'm going to do it like that is not because I don't like writing. I love writing. But I think that maybe it might be good for you guys to see how to do it using a calculator. Are we cool? So I'm going to plug in a bunch of calculator stuff. But anyway, can you guys remember, do you guys remember the quadratic equation? Or at least, do you remember the story about the boy in the quadratic equation? And you guys need to keep talking to me. If you don't know, say IDK, but if you do know, start telling me parts of the story that was the quadratic equation story. Ramona, you don't remember? Really? None of you guys remember? Well, there's a story about a boy, and all right. Let me give you the highlights. Justice remembers. He was the boy. That's why. Actually, Andre was the boy, because Andre's super nerdy and whatever. Kind of a negative guy. All right. Anyway. All right. So there's this boy. All right. Dude was negative. Got it? Boy, he was negative. And he was kind of a square. Oh, wait, no. He was unsure about going to some radical party. Got it? So there was a boy, he was a negative boy, he was unsure, radical party. He went to the party anyway. At the party, boy was a square. Which basically means he was kind of a prude, or I'm not sure, whatever. Alright, so the boy was a square, and he missed out on talking to 4 awesome chicks. Laura, were you not here for the last class? The party was over at 2 a.m. All right. There we go. Justice got it. A negative boy. He was unsure about going to a party that was radical. I like that. All right. The boy was a square, and because he was a square, he missed out on his chance to talk to 4 awesome chicks. The party ended at 2 a.m. I love it. Good. Great, Justice. You remember it. Laura and Makana, were you guys here for the last class? I'm just wondering because if you weren't and you guys just came in, you guys are wondering what the heck is going on. And I can't tell, Raimana, are you saying like, okay? Anyway, what this is this is just a tricky way of having you guys memorize the quadratic equation. The way you memorize the quadratic, or the way you write down the quadratic equation, is you do this. Okay, I don't want you to pay attention to what's up here. I only want you to pay attention to what's on the bottom over here. So if you have ax squared plus bx plus c equals 0. Okay, if you have that, then the answer to it is x is equal to negative b plus or minus the square root of b squared, missed out on 4 awesome chicks. You guys got that so far? And the whole thing was over at 2 a.m. So if you have this, if we start off with ax squared plus bx plus c equals 0, and that's important, okay, then the answer is negative b plus or minus the square root of b squared minus 4ac all over at 2a. Oh, all over 2a. And the reason why I came up with this crazy story is basically this helps me memorize this formula right here. See, the story is a negative boy was unsure. The unsure part is the plus or minus. The radical is another word for the square root. So the radical party, and at the party, within the party, he was a kind of a square, so we got b squared, the boy was square. He missed out on talking to 4 awesome chicks, so that's why you got 4ac, and the whole thing was over at 2 a.m. Do you see? Do you see the craziness that is my brain? I know. It's crazy, huh? I'll tell you what I'm going to do is I'm going to just basically make a Google Doc. Alright, I want you to write that down. I'll give you a second. Write this down. Put an if over there, and then put a then over here. So if you start here, then you get this. And let me know if my audio kicks out, because I definitely want to know that. And while you guys write that down, let me just kind of start working on something else. We're just going to pull up some random doc. I'll just copy and paste this just so I have all my formulas here. When I was in college, I learned to type math really quickly. I could type math so quickly that I could actually type all of my notes out faster than I could handwrite them in math. And the way that I learned how to do that is I learned how to use this code like this thing right here. You don't need to do that. Don't worry about that. I really am just using this because there's no real good way to type in mathematics. So I pulled up this thing because this thing will show you the math that I want to type to you. Are we cool? Are you done writing it down? Yes? No? I need more time? I'm fanatic about having you guys write to me. Okay, good. So let's take a look at this thing right here. And, all right, here we go. Warm up. Okay, here, let's take a look at this one. X squared plus 8x minus 1. First thing I want you to do, identify for me A, B, and C. What is A? Type it in. A equals what? B equals what? And C equals what? What is A, B, and C? I guess you know what? I guess the first question I need to ask you is, write this problem down. X squared plus 8x minus 1 equals 0. Write that down on a piece of paper. No, this is quad 8. But I did promise someone I would work on quad 7, but I'm on quad 8 by now. All right, Laura. Laura, before I go, make sure we cover quad 8, or quad 7, whatever. All right. Yes, that's an 8x. I don't know, can you see it? Here. There we go, right here. Okay, if you're done writing it down, here's my first question. Is our question of this form, does it look like ax squared plus bx plus c equals 0? Yes or no? Okay. Now, if it is of that form, then here's my next question. What is A, what is B, and what is C? So you're telling me that x squared plus 8x minus 1 is of this form, ax squared plus bx plus c. And my question is, what is a, b, and c? And you told me, okay, well, it's easy. I can just read it. It's 1, 8, and negative 1. Can everyone see that? So all you do to use this quadratic equation is you literally write it down, okay? So I wrote it again, but instead of a b, I'm going to put 8. And instead of an a, I'm going to put 1. Instead of a c, I'm going to put negative 1. Oops. And instead of another a, I'm going to put a 1. That's it. That's all I'm going to do. I mean, that's not all I mean, do you understand that step? This is actually the most important step. Audio, check. Audio, check. Check audio. All right, good. Do you understand this step that I did? All I did was you told me that A was 1, B was 8, and C was negative 1. So all I did was I plugged in 8 for B, 8 squared. A is 1, C is negative 1. Notice how I put a parentheses around this negative 1. I didn't want to just make it 4 times 1 times negative, or times negative 1 without the parentheses, because then it would look to me like 4 times 1 minus 1. I need to make sure I multiply this by negative 1. That would make me happier. We cool? Divided by 2 times 1. Are we cool with this so far? Okay. All right. Well, let's continue this idea. I'm going to do this slowly. I'm going to go, okay, well, I'll change this to a 64, and I'll change this to a 4 plus 1. I'll change that to a 2. Does everyone see what I did? Because 8 squared is 64, and 4 times 1 is 4, times negative 1 is negative 4, but I have a minus negative 4, so I really should put a plus 4. Are you sure you've seen everything in this thing? Oh, and then the 2 times 1 is 2. If it's all right with you, I'm going to change that to a, not a 64 plus 4, I'm just going to change it to straight up 68. Because 64 plus 4 is 68. Is that all right? Yes, no, we good? Okay, awesome. By the way, I don't know what the square root of 68 is. I'm just going to type it in. Square root 68. It's probably going to be some ugly decimal number. I don't care. 8.246. Okay, all right, let's try that. So what I'm dealing with here is instead of the square root of 68, what I'm dealing with here is this thing is 8.268. Is that it? 8.246. Sorry, not even close. 246. So I have negative 8 plus 8.246 divided by 2, and I have negative 8 minus 8.246 divided by 2. Those are my two answers. Are we cool? All right. So let's just do the plus version first. What is 8 plus that number divided by 2? I don't think Google knows what to do with that. Let me just do that. There we go. 12.1231. Everyone agree? Everyone understand where I got that? Oh, I'm sorry. Oops, I made a mistake. There should be a negative out in front. Because I need to figure out what negative 8 plus 8.246 divided by 2 is. Everyone agree with that? Agree. Justice, what are you saying? You don't, because I forgot the negative? Okay, awesome. That's what you got, Justice? Are you talking about you did it on your calculator and that's what you got? Okay, awesome, because you did it wrong. That is totally wrong. Not acceptable. Wrong, wrong, wrong. Look, check this out. If I look at how I should plug this into my calculator, this is negative 8 plus 8.246, and I divide all of that by 2. When I plugged it into a calculator or Google or whatever, I just did negative 8 plus, by the way, this is 8.246. That's the square root, that's the same thing. I did negative 8 or plus 8.246 divided by 2. Now look at how Google has translated it. Google said, oh, what you mean is negative 8 plus 8.246 divided by 2. And I would say, no, that's not what I meant. What I want you to do is I want you to add the negative 8 plus 8.246 first, and then divide the entire thing by 2. What Google is saying, oh, you want me to take 8.246, divide that by 2, and then add it to negative 8. And you can't really blame Google. You have to blame yourself. Because technically what you told the calculator is this, and if the calculator follows PEMDAS, please excuse my dear Aunt Sally, division comes before addition. So you told the calculator to do this division first, and then add that to this negative 8. Do you see what I'm getting at here? Which is why Mr. Dalday is often such a jerk about putting in the parentheses. Because if I plug that in, that is a totally different answer. That's not the same. Negative 3.877 is not the same as 0.123. So which is the right one? Well, it's this one. Because you told the calculator what to do correctly. You said, I want to take that negative 8, I want to add it to the 8.246 first, and then I divide the entire thing, whatever the answer I get from that, by 2. That's what I want to do. If I did it the other way, I would be in trouble. I'm only pointing this out to you. I only led you down the wrong path. I did it on purpose because I don't want you to forget it. Are we cool? So that's one of my answers. My other answer is if I change this plus to a minus. So my answer is 0.123 or negative 0.123. And look, check this out. If I go to Desmos, and I graph my thing, what was it? X squared plus 8x minus 1. X squared plus 8x minus 1. And you look at where it crosses. It crosses at 0.123. Do you see that? It also crosses at negative 0.8123. That's the answer we got, negative 0.8123. Are we cool with this? We didn't do complete the square. We did a completely different thing. We used this formula, the negative boy, plus I'm unsure about going to a radical party. The dude was kind of a square, and so he missed out on talking to 4 awesome chicks, and the party was over at 2 a.m. That's what we did. We didn't do complete the square here. We didn't factor. We just plugged it into this ugly equation, where the hardest part about that equation was plugging it into the calculator. I don't say that as in, you know, oh, look how easy this whole thing is because the hardest thing is to plug it into the calculator. No, plugging it into the calculator takes some skill. So by the way, my answer is x equals 0.123 or x equals negative 8.123. So those are my two answers. Are we cool? Yes, no, I don't get it. I hate you. You're ugly. Okay. Well, I mean, not you're ugly, but I'm just saying, I'm answering on your behalf. Anyway. Oh, really? I'm ugly then, huh? All right, fine. No. All right. Here's the thing. You could do complete the square with this equation. That is possible to do. You can't use factoring to do this, to get this answer. And I'll tell you why you can't use factoring. Because these numbers don't land nicely, the zeros don't land nicely on integers. If this thing crossed at 1 instead of 0.123, and this thing crossed at negative 8 instead of negative 8.123, then you could have gone back and factored it. And that would have been the quickest, simplest, easy way. But like I said, that's like a fly swatter. It's nice, it's clean, it's simple, but it doesn't always do the trick. The complete the square method and the quadratic equation, which is really doing the same thing, but the quadratic equation is kind of ugly, it's kind of a lot, but it will definitely do the job. And it will do a job whether it falls nicely on an integer or doesn't fall nicely on an integer, as this one doesn't. So if you ask me, I guess the question is, if you ask me which one is better, I guess if you ask me, if I were going into a jungle, what would I want to take? A fly swatter or a bazooka? The bazooka will definitely do the job if I encounter any animal. The fly swatter will do the job if I encounter only special kinds of animals. What would you answer? Would you want to take the bazooka or would you want to take the fly swatter? Can you guys even hear me? All right, Rainey's saying the bazooka. All right, anybody else? Come on, you guys, be bold with your answers. Which one would you rather take into the jungle? A bazooka or a fly swatter? The fly swatter only works with certain animals. The bazooka will Garensville work every time. It's a simple question. All right, I've got a bunch of people saying bazooka. And here's where I actually disagree with you. It's not to say that you're wrong. Here's where I disagree with you. In fact, I like that I just came up with this. Yeah, I'm patting myself on the back as we speak. I like that I came up just... I I just came up with this analogy because it makes sense to me, is I'd rather take both. Because there's probably a lot of flies and mosquitoes inside of the jungle, so I'd want to take the fly swatter to kill those quickly. I don't want to have to set up a bazooka every time I want to kill a fly. But I'd also like to take the bazooka along with me, just in case I encounter an animal much bigger than a fly. Does that make sense? So what I'm saying here is that now that I taught you the quadratic equation, and it will kill any kind of quadratic formula, that doesn't mean you throw out the ideas of factoring. Factoring works because it's much quicker, it's much cleaner, you can get the answer immediately. If you had to put everything through the quadratic equation each time and you get simple answers, that would be like trying to kill every single fly in the jungle with a bazooka. Yes, it will work. It will be tedious. It won't. It will probably take you a long time and all of that kind of stuff. The person with the fly swatter can go and smack, 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 done. Does that make sense? But have the bazooka ready just in case you encounter problems that can't be factored nicely. Because if it could be factored nicely, you can still use the quadratic equation on it. It takes longer. All right, let's try another problem. Oh, I forgot to do this with you guys. This is an exercise, maybe in square roots and whatnot. I want you guys just to practice your calculator skills with me. Somebody find for me the square root of 8. Someone find the, what is the square root of 8? Oh, I see what they're doing for you. All right. If you have a calculator available, quite often what you'll want to do is just plug it straight into your calculator and not even have to worry about it. But one of the techniques that we use, especially when we don't have calculators, and I should show you this, is this. Okay? I can pull out certain numbers out of this square root. And this actually might be a good exercise for me to do. Okay. All right, let me just show you how to do this. First of all, I'm going to start off with, there's a special set of numbers that I want everyone to always memorize. And those numbers are this. I want you to memorize these numbers. I want you to be familiar with where they come from. I'll tell you them. Ready? 1, 2, 4, 9, 16, 16, 25, 36, 49, 84, no, 64, 81, 100, 111. Is it 111? No, it's 121. 144, 169, I believe. Have you guys seen these numbers? Yeah, obviously you've seen these numbers. I've learned how to count up to 200, but have you seen, do you understand why they are special numbers? Okay, why are they special numbers, Jillian? They're perfect squares, exactly. Yes, they're very special numbers because, actually, oops, 2 isn't a part of that set. I'm sorry, I don't know why I put that there. 1, 4, 9. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, and so on and so forth. All right. The reason why I want you to think of those numbers in the back of your head is because if we have something like this, square root of 8, okay? If I have the square root of 8, can 8 be divided by a number that is in our list? So See this list? Can 8 be divided nicely by any of these numbers? And if so, what is it? 4. Perfect. I agree with you. So the square root of 8 is really the same thing as the square root of 4 times 2. Agree? Which is the same thing as the square root of 4 times the square root of 2. Agreed? Yes? No? Okay, awesome. Now the reason why I made this the perfect square is because I know what the square root of 4 is. That's pretty easy. What's the square root of 4? 2. So this 2 right here comes from that square root of 4. That's where that 2 comes from. The second 2 comes from this leftover 2 over here. And usually when we write this, we don't need to put the times symbol in between this thing right here. So we write this as 2 root 2. So if I ask you, what is the square root of 8 the same as? You would say 2 times the square root of 2. Because watch. The square root of 8 is 2.82 whatever, like what Laura said earlier. And what is 2 times the square root of 2? Same exact number. So what this thing is asking you is put this in the simplest form without using a decimal. That's what it's saying. Does that make sense? And you know what? Before I get into super heavy quadratic equation, this is actually, I feel very comfortable with sticking with this. Are you guys still alive? All right, good. Why don't we try a few more of these and then we'll finish. And then before I leave, Laura, I need to work with you. I want to do this maybe for another 5-10 minutes, and then I'll work with you, Laura, and then I actually got to jump over to physics. But let's do this. All right, what is the square root of 54? Okay, I don't want this in a decimal, but what I want to know is there a number from my list? I'll show you the list again. See this list? That can go nicely into 54. Okay, good. Laura, I'm glad you figured it out. I'm going to go back to my original question. I have the square root of 54. Is there a number that one of these factors goes nicely into? 9. Yeah, all right, good. So this is the same as, all right, so you're saying that the square root of 54 all right, so you're telling me that the square root of 54 is 9 times 6, is the square root of 9 times 6, right? All right, so that's equal to the square root of 9 times the square root of 6, right? Which is equal to, what's the square root of 9? 3, good. So it's 3 times the square root of 6. This 3 comes from the square root of 9. This square root of 6 was just left over. Can I continue this pattern? Can 6 be divided nicely by any one of these numbers, these special numbers over here? $36? No. I'm saying, can any one of these numbers go nicely into 6? 36 is bigger than 6. There's no way I can fit 36 into 6. Yeah, the answer is no. So at this point, I'm done. The square root of 54 is the same as what we say, how we say it. We say 3 root 6. So 3 root 6 is 7.3484. Or 7.348 as what you call it, Laura says. But if I type in square root of 54, 7.384. Same number. Are we cool with this? All I'm showing you is how to simplify these square root functions. Because you're going to see a lot of these square root functions when you get to the quadratic equation. All right, let's try a harder one. Let's do 11. Okay? All right. Is there a number from our list that nicely goes into 50? And if so, what is it? Yes, Rainey, I will definitely help you out with that, and I will do that once we finish this problem. $25. I agree with you, Jillian. So, I'm actually not even going to write anything down. I want you to write it down. I'm just going to talk you through it. The square root of 50 is the same as square root of 25 times 2. Am I correct? So what I'm saying here is that really what I'm dealing with, instead of the square root of 50, I'm talking about the square root of 25 times the square root of 2. And we all know what the square root of 25 is. It's simply what? 5. Perfect. So I would venture to say that the square root of 50 is equal to 5 root 2. Which is 7.07. See this number? I'm wondering if that's true. Let me just try it. What is the square root of 50? 7.07. Awesome. Do you guys see what we did here? What we're doing is called factoring out the perfect squares. We're trying to pull out numbers, but we're only pulling out specific kind of numbers. The ones that have nice square roots. Okay, Rainey, you need help with turning something from standard form into vertex form. And you don't feel like the videos that I made were sufficient for that, so you want me to go over it in class. Is that correct? Don't worry, I'm not taking offense to that. I'm just saying that that's what you want. Okay. All right. Let me go over this real quickly with you because I technically should be finished at 11:10, and I want to get to. I should have started up my physics class with another student, but I will show you this really quickly. Rainey, how do you feel about the completing the square method? You feel good about it. Okay, good. Because that means this will actually go quickly. Turning something from standard form to vertex form is doing the complete the square method with an extra, but actually it's actually easier than doing the full on complete the square method. Now, 3x squared plus 5x plus 1. Let's talk about this one real quick. 3x squared plus 5x plus 1. All right. 3x squared plus 5x, oops. 3x squared plus 5x plus 1. Now, when we did the complete the square, we set this equal to 0. And we were happy. Okay? Right? And what we did was we put a random space right here. again, don't worry about what I'm typing here. Just worry about what's coming on here. Okay? But before we put that random space, what we actually did was we divided everything by 3. Right? We didn't want a number in front of the x squared term. Right? Yes? Okay. Now, what I'm going to do is instead of putting a 0, because that's not what we want, this thing is equal to f of x. And I'm still going to divide everything by 3, so let me do that right here. 5 over 3. Oops. 1 over 3. All right, do you see what I did, Rainey? Did I lose you at any point? Okay, let me show you what I got. Squared. All right. I originally started with 3x squared plus 5x plus 1 equals f of x. All I did was I took that 3 that goes in front of the x squared and I divided everything by 3. So when I divide the first thing by 3, this becomes a 1, which is the whole point of me doing that, because I want this to be a 1. This becomes 5/3, this becomes 1/3, and this becomes f of x over 3. Are we happy with that? And I just so happened to take the liberty to put this randomly big space over here. Okay, now what I'm going to do in the name of completing the square, I'm going to add some number. Do you know what that number is? Does anyone know what that number is? It's kind of a tough one. It's 25 over 36. Right? I think it is. Yeah, 25 over 36. Go for it. You're allowed to ask me. Where did you get 25 over 36? I'm waiting for you to ask me. I don't want to tell you until I ask you. Where did I get that? Oh, okay. Well, I took the 5 over 3 and I divided it by 2. Okay, I'm going to work below this. This will be side work. I took the 5 over 3. I divided it by 2. So that becomes 5 over 6. Or, I'm sorry, if I did too many steps, I put a 2 in the bottom, which is basically 5 over 6. Right? And then what I did was I squared that. I squared that. So that's where I got 5 squared is 25, 6 squared is 36. That's where I got the 25 over 36. Are we cool? This is just complete the square. And you told me that you were comfortable with completing the square, so I did a few steps in my head. Okay? All right, but I can't just go around adding 25 over 36. I have to subtract it from the same side as well. Are we cool with this? So do you understand how I got this line below? Because ultimately there wasn't anything there. There was just this big space that was there. But what I can do is I can fill in that space by adding 0 to it, or a very special kind of 0. How's about this kind of 0? 25 over 36 minus 25 over 36. That's still 0. I didn't change anything. I just kind of played with it a little bit. We cool? All right. Now, let's think about this. I'm going to mess with these first 3 numbers here. And this is, I'm not doing anything beyond completing the square. This is still completing the square. I'll copy and paste this. But instead, I'm going to make those first 3 numbers, I'm going to delete that, and I'm going to make it like this. Wait a second, why is this not registering it? I gotta reload this, 1 second. Did the audio cut out? Hello? Check. Check. Hello? Check. Hello? Check. Hello? Hello? Check. Hello? Okay, good. Sorry about that. Yeah. Sometimes it just got killed. Okay, I'm sorry. I don't remember. I think that my answer that I had up here was this. I noticed that my computer just started junking out, so I apologize. Anyway, let me write up what I think that was on there, and hopefully you guys wrote it down so you guys remember. It was x squared plus 5/3 x plus 25 over 36 minus that plus 1/3 equals f of x divided by 3. Is that correct? That's what I had written down, right? Hello? Oh wait, you can't see my computer screen. Never mind. Check 1, 2. Can you hear me still? Hello? Alright. Can you see my computer screen? Yes? No? Okay. Is this what we had written down? The last thing we had written down? Yes? No? I don't know. I think it was. I'm just doing this off the top of my head, off from memory. X squared plus 5/3. Yeah, alright, good. Alright, and you understand how we got there, right, Rainey? Okay. I need you to respond, because I'm already 17 minutes past the time I need to end, so I need you guys to tell me whether or not you guys can hear me. Yes, no? I mean, I'm not getting angry. I guess maybe it sounds like I'm getting angry, but yes, please tell me back, because I'm taking time out of my students' physics class so I can teach you guys this stuff. So I need you to respond. I'm basically going to rewrite that same equation below. It's just this first 3 terms is going to be this. I'm going to change it. This becomes x minus, oh no, x plus 5/6 squared. All right, I wrote the first 3 numbers as this, x plus 5/6 squared. I mean, that's just completing the square stuff. Are we cool? In fact, while I'm at it, why don't I just do this? Change this 1/3 to 12/36. Are we good? All I did was I changed this number 1/3 to make it 12/36. You understand why? Okay, good. Because I want to combine fractions over here in these last 2, so I just want to make them same denominator. But this is the same as 1/3. All right. And if you don't believe me about this thing right here, change these first 3 numbers into this 2 numbers squared. Multiply it out, FOIL it out, and you'll see that this 2 numbers, this term right here was the same as these first 3 numbers. But anyway, let me do this where I'm going to make this a negative 13/36, because 25 minus 12, or I'm sorry, negative 25 plus 12 is negative 13, I believe, over 36. And then the last step I'm going to do is this. It's very simple. I'm just going to multiply everything by 3. So that puts a 3 out in front here. That makes this a 12. And then what that does is it gets rid of that 1/3. The reason why I multiply by 3 is because I have this thing is equal to f of x over 3, and I want it to be equal to just straight up f of x. So in order to get rid of that 3 that's in the bottom, I just multiplied this by 3, and this by 3, and this by 3. Everything by 3. I have an extra parentheses in there. So my answer is 3 times x plus 5/6 squared minus 13/12. So I would venture to say that if I took this number right here, if I wanted to graph this, what I would do is this graph would move 13/12 down. It would move to the left No? Yeah, it would move to the left 5 over 6 units, and it would also be stretched vertically by 3. If I were to go to Desmos and I go 3x squared plus 5x plus 1 plus 1. Okay, this graph, this parabola, moved to the left. Okay, wait. Let me graph another parabola. X squared. All right, the minus 13 over 12 is there. See how I took the parabola and I pushed it down 13 over 12. I'm going to put a plus 5 over 6 over here, and look, it's the same spot. It moved to the left 5 over 6. Does that make sense? This blue parabola doesn't look like this red parabola, so that's why there was that 3 out in front. So basically now, those parabolas are the exact same. The computer graphed this thing for me, and I graphed this thing for you. They're the same graph. What I'm doing when I'm changing something from standard form to vertex form is I'm not changing the equation itself. I'm just changing how it looks. Now, this one looks a lot more horrible, but to be honest with you, you guys once told me that you guys actually prefer this one because it's easier to graph in your head. You can say, oh, I'm just going to move that thing 13 over 12 units down and 5 over 6 units to the left and stretch it vertically by 3. Does that make sense? And the way we get from here to here is we use this awesome trick called completing the square. Are we cool with that? Awesome. You know what? Now that I have you guys here, I almost want to do this. No, never mind. I think I'm going to come back to this on Friday. We're going to revisit this idea. So keep this in the back of your head, please. All right, I got to go. I got to go apologize to my other student and, reschedule my physics class. But you know what? I don't want to say that because I don't want you to feel bad about asking me questions. Please make sure you do so. And I probably should have maybe gone over this. I hope that me going over this again helps you. Helps clear it up for you. All right. I'll talk to you later. Okay, bye.